I will be only teaching in the board and you have to follow my board. Plastic, siliciclastic. Now this plastic, siliciclastic, it can be of different type. I can have a conglomerate, I can have a plastic rock which may be a conglomerate. I can also have a breccia. Of course, breccia is not truly formed by the sedimentary process. It may be a fault generated breccia. It can also be a sedimentologic breccia, where I can get a sedimentologic breccia where there is a steep slope failure and the sediment do not get any chance to be a part of the flow process. I have a mass failure because of any slope and the entire material is dumped at the base of the slope. I can have a breccia formed in the sedimentary process. I can also have a breccia that is formed by the tectonic process, what we call the fault breccia. So when I talk about breccia, I am basically referring those breccia which are basically formed by the sedimentary process. So I can have a breccia, I can have a conglomerate, I can have a sandstone, and I can have shale. All these they are plastic or siliciclastic. What is the fundamental property of a plastic or siliciclastic? All these rocks, they will show you fragmentary texture. Fragmentary texture. That is the fundamental property. Fragmentary texture. What is fragmentary texture? That if I see that rock under thin section, individual grain, they are not matching with its adjacent grain. Individual grain has its own shape and no control of the adjacent grains of the shape of the individual grain. The individual grain, they are basically the formed and are transported in the form of a detritus. Detritus. So they are fragmentary. They are the assemblage of fragments. Assemblage of fragments, and there will be no relation of one fragment shape with the other shape. So all these rocks, they show a fragmentary texture. Then I can have different kind of chemical sedimentary. Chemical sedimentary. Now this chemical sedimentary rock, there is no way it is related to the fragmentary. It is no way related to the weathering, erosion, and the mechanical transport of the sediment. All these plastic sediment, they are actually mechanically transported sediment. Mechanically transported sediment. They are mechanically transported sediment. They are mechanically transported. That means there is weathering, there is erosion, and the different sediment grains, the weathering profile is formed, the soil profile is formed, and the sediment that is released by that is transported by the wind, by water or ice, and get deposited at some place that we call the siliciclastic or the fragmentary texture and the mechanically transported. Now the chemical rock. Now in the chemical rock, I can have different kinds of chemical rock. I can have the carbonate or dolomite. We can have evaporite. We can have phosphorite. We can have chart, or we can have iron formation. All these, they are basically the chemical sedimentary rock. In one process or the another, these different kinds of chemical sedimentary rock, like the carbonate, evaporite, phosphorite, chart, iron formation, all these chemical sedimentary rock, they get formed. Then you have another unit of sedimentary rock, what we commonly refer to as volcaniclastic rock. Volcaniclastic. What is volcaniclastic rock? That it is of igneous origin, but the process by which the igneous thing is being deposited, that is in the form of plastic mechanical process. So a volcanic origin material deposited by the sedimentary process, volcanic originated material deposited by the sedimentary process, that is known as the volcaniclastic rock. Now this volcaniclastic rock, it can again be coarse-grained or it can be fine. When you have the fine grain, you basically refer those things as tube. Tube. Tube is the volcanic ash, which is basically settled from the suspension through air. Through air, the suspension settlement of the volcanic ash that basically result in the rock record as tube. Suspension settlement of volcanic ash through air that basically result in the formation of tube in the geological record. So that is actually the fine grained volcanic plastic rock. We also have another clan of sedimentary rock. What is organosedimentary? Organosedimentary. Organosedimentary rock. Where I get coal. Organosedimentary rock, where we get coal, and it is really not rock, but the material formed by the sedimentary process and found in the rock. That is what is the oil and gas. Organosedimentary. So you can see the entire gamut of the sedimentary rock, that how the different kinds of sedimentary rock, right from the plastic, silicy plastic, then the chemical, and this, and finally the volcanic plastic and the organosedimentary. So is a huge gamut of the sedimentary rock that basically we find. Now, if you see the distribution of the sedimentary rock on the surface of the earth, how the sedimentary rock, they are basically distributed on the surface of the earth, about 10% of the continental surface. The 10% of the continental surface that is either covered by ice or water. 10%. I am only talking about the continental surface. Okay? I am talking about the continental surface. 10% of continental surface, it is covered by ice or water. Out of the rest 90%, if you see the African craton, that is mostly occupied by metamorphic rock. African craton. Whereas the North America and the Eurasia, they are the dominant is the sedimentary. Okay, they are the domination is of sedimentary. So you see that it is that on the surface of the earth, the distribution of the rocks is not homogeneous. It is a heterogeneous distribution. And this heterogeneous distribution, sometimes some portion that it is more of the craton, that is the gneissic craton, that the metamorphic rock, the craton, and the sedimentary basins, they contain the. If you see the India, that what is the geology of India? What is the geology of India? If you see the entire peninsular India, they are basically some craton which are originally the microcraton. What we talk about the microcraton, the Dharwar craton, the Singhbhum craton, the Bastar craton, the Aravalli craton. All these craton, they are stitched through some orogenic bed. You get the different, you get the CITZ, you get the Eastern Ghat, you get the Southern Granulite Belt, what is the Palghat shear zone. So all these shear zones, they basically cause the stitching of the cratons, what we call the stitching of the cratons. And then you get the entire peninsular geometry. Now what you get on that, you get the different basins which basically host the sedimentary rock. What are those basins? There are different basins which are in the Precambrian basins, the Vindhyan, the Chhattisgarh, the Kadapa, the Pranita Godavari. All these are the Precambrian basins. Then you get the Phanerozoic basin. Starts with the Gondwana. You get the Gondwana basin. Then you get the different basins, the Jurassic basins, that is the Kaj basins, that is the Trichy basins, that is the Cretaceous basins, and finally the Quaternary basins. So you see the cratons and the basins, they basically host, the cratons host the igneous metamorphic rock, the basins host the sedimentary rock. It is a juxtaposition of the craton and the basin with one another, then which is dominating what, and that basically reflects that how much is the relative importance of the sedimentary rock. So the relative abundance of the sedimentary rock, if you see that this is the general condition. This is the general condition. Now let us come. Please stop me if you feel that there is some question. Now we come on to our first discussion that will be mostly confined into the clastic sedimentary rock. The clastic sedimentary rock, then how really the sediments they are generated, how sediments are generated, how the generated sediment that basically is transported to the basin, and then in the basin how it is deposited. So first to start with the how sediment is generated. The sediment generation, that is one of the major point, that how really sediment, I'm just giving you a general idea. I will come to board afterwards. Just listen to me. Suppose the weathering reaction on the continent. Just I give you first a statement. I just give you a statement, then I will come to the how we describe this statement. It has been calculated. All of you are aware of Deccan Trap? All of you are aware of Deccan Trap. Now what is it? It is a volcanic rock trap. Okay. People have estimated that if entire Deccan Trap is weathered and that is supply the sediment, then what will happen? If entire Deccan Trap is weathered and there is no Deccan Trap rock now, and all Deccan Trap that has become a sediment, then what will happen to the earth condition? It is estimated in that case 20% of the earth atmosphere carbon dioxide pressure will decrease. 20% of the earth's atmosphere carbon dioxide volume, not pressure, I'm wrong. 20% carbon dioxide volume of the atmosphere will decrease if you totally weather the Deccan Trap. And that will cause 0.55 degrees centigrade decrease in the temperature of the earth. Am I clear?
Yes, sir.
Yes, sir.
Now, what does that means? That the basalt weathering, it is a carbon dioxide consuming reaction. That any basalt weathering reaction which create the sediment, that is a carbon dioxide consuming reaction. Now, this is one that means what basalt weathering is actually? It is a silicate weathering I am talking about. It is a silicate weathering. So silicate weathering, it is a carbon dioxide absorbing reaction. This is number one. Now you see that in the ocean, carbonates get deposited. Now, what is the carbonate deposition reaction? That is the carbon dioxide release reaction. So any carbonate precipitation releases the carbon dioxide. If you increase the carbon dioxide pressure, carbonate goes into dissolution. If you carbonate gets precipitated, carbon dioxide released. Now the thing is that carbon dioxide gets released by carbonate precipitation, and silicate weathering that decreases the carbon dioxide pressure. These two actually balances each other. You understand that silicate, that is withdrawing carbon dioxide from atmosphere, carbonate precipitation releasing carbon dioxide in the atmosphere. And if there is a imbalance between the two, then what will happen? Either earth temperature will decrease or earth temperature will increase. But if you feel that it is really the earth temperature that is in a balance, then I am not going into the present day controversy of the greenhouse gas. There is a lot of, some people believe, some people do not believe. I am not going into. I am talking about the basic science. That I will discuss that how really it happens. Now, where from the carbon in the ocean is coming. Where from the carbon in the ocean is coming. That so much of calcium carbonate, so much of oceanic light, and all the oceanic light that basically requires the carbon. Where from? It all comes from the weathering of the silicates on the continent. It all comes from the weathering. And now that carbon, it is basically through the riverine influx, it is supplied to the ocean in 4 different forms. In 4 different forms. What we call the dissolved organic carbon. जिसको हम लोग कहते हैं DOC, dissolved inorganic carbon. DIC, then particulate organic carbon, POC, and particulate inorganic carbon. What we call the PIC. So DOC, DIC, POC, PIC. In these 4 different forms, the carbon that is basically transported from the continent to the ocean. And this from this continent to the ocean, this supply of carbon. Suppose you see the presence of carbon. What is the basic ingredients of our body? If you burn me, what do you basically get? You get the carbon. It is the organic form of carbon. And what is in the limestone? You also get carbon, that is the inorganic form of carbon. So inorganic form of carbon in the limestone and the organic form of carbon in the all organic bodies, including us. So all these carbons, this carbon in different form, that basically goes into either by the weathering of the carbonate, or by means of different organic body. Where from we get the carbon? This inorganic carbon from the weathering of the carbonate rock, and organic carbon, which basically is the responsible from the carbon dioxide pressure of the atmosphere. These two basically goes into the ocean, and then you get the calcium carbonate precipitation, which is absolutely necessary for the marine life. You think of all bivalves, you think of all gastropods, you think of all the invertebrate organisms which make their shell by the calcium carbonate. If the carbon is not supplied from the continent, these organisms, they will not live. Their existence is completely dependent upon the continental, and there the supply of the carbon from the continental either by the weathering of the carbonate rock or from the atmospheric carbon dioxide, and that basically get recycled in the organic carbon form. So these two, this is a huge balance that basically going on. And that cycle of the sedimentology, it is basically driving the entire organic cycle, right from our life to the marine life. So all these, they are basically circulated by the how really carbon is circulated from the organic cycle to the inorganic cycle. Suppose I just give you one example. The initial Precambrian Earth. That means if we consider that the Earth was formed at about 4.3 to 4.4 billion years ago, then up to 540 million years, it is the Precambrian Earth. And it is generally believed that the Precambrian Earth was lifeless. There was life, but not in the form what we know today. I will not go into that debate. We can discuss it separately. What kind of life was there? But generally, the way we see the life, that was not there in the Precambrian. And then the invertebrate and vertebrate life, it started coming from the Cambrian, and you see today the explosion of life. Now, whether all sorts of life, that life was in the basic ingredient is carbon. When there was no life, where was this carbon? Is this new carbon added to the earth when life has come? No. The carbon budget is fixed in the earth. So how, when the life, it came in a large way, what supplied the carbon for the life? What supplied the carbon for the life? Where from that carbon came? You see, this is basically the budget of the inorganic carbon and the organic carbon. That if you have the total carbon budget of the earth is not getting changed. You are only getting the change from the how you really take. Can anyone tell me that how a inorganic carbon get involved in an organic path? How can I make a carbon which is inorganic and I make it an organic carbon? What is the process? Can anyone tell me? Hello, just reply. Is my question is clear to you? हेलो
Yes, sir.
जोर से बोलो भाई, जोर से बोलो. देखो मैं कितना चिल्ला रहा हूँ.
Sir, by photosynthesis?
Yes. Who are you?
Sir, Utkarsh.
Okay. So the only reaction which can make a inorganic carbon to a organic carbon is photosynthesis. Without photosynthesis, I cannot take a inorganic carbon into the organic world. So this is how by photosynthesis, all photosynthetic, not only plants, there are algae also, and there are many other organisms who do the photosynthesis. It is not that only large plants they do the photosynthesis. Any photosynthesis reaction that basically causes the inorganic carbon that is present in the atmosphere to enter into the world of the organic carbon. And this is how the entire budget is fixed. Now, if we consider that, yes, weathering has a big role in this entire process, that this is the weathering which basically drives the entire control of the carbon, and as well as, because when we talk about the carbon dioxide, greenhouse gas बढ़ रहा है भाई, ये carbon dioxide का pressure बढ़ रहा है, how really we can decrease the carbon dioxide pressure? One major way of decreasing the carbon dioxide pressure is the weathering reaction. And if we then say that if we see that how really we can very simplify the simplified diagram where you have either in the snow or in form of rain. In form of rain, you basically get the availability of water. Water a major carrier. Wind is also equally important carrier of sediment. So water is a major carrier. And the amount of water that is available on the surface, about 2/3 of that water that gets lost by evaporation or evapotranspiration. And the rest one third of water, it either moves as a surface flow or it moves as a groundwater flow. So the water which is available by the melting of the ice or from the rain, that either stays on the surface and moves as a surface flow or it moves as a groundwater flow. The amount of water that basically rests at a particular environment that controls the amount of weathering in that environment. The water availability is a major concern of the weathering of the, not only water, along with water, what is important is climate, type of rock, 3 vegetation, and number 4 physiography. Along with water, this, what is the climatic zone? I am basically there. At what climatic zone? It can be a temperate climate, it can be a tropical climate, you can be a subtropical climate. So there are, climate means that the amount of the rainfall and the temperature, average temperature. So the water availability and the temperature, these two become the most important in terms of climate. The type of rock, what we are talking about, I'm talking about a rock which is a very quartz-rich rock, which is not a quartz-rich rock. So what kind of rock? What is the unstable character of the minerals of that rock? So all these, that basically, it also depends upon the vegetation. The thickly vegetated area of the tropical forest, it is the most important area for the weathering reaction, and the physiography. So all these role of physiography I will come separately, because it is a very important role, that whether you have steep slopes that is available in a particular area, or you have a very gentle, rounded, sub-rounded slopes that is there. These two are also very important for the any weathering reaction and the type of sediment that it will be supplied. So this is basically now the reaction, the weathering reaction. Whatever the weathering reaction, there are different kinds of weathering reaction. Number one, the weathering reaction, what we call the dissolution. Dissolution. That is the number of the weathering reaction. Now we are coming to weathering reaction in the generation of the sediment. Weathering reaction and generation of the sediment. So dissolution. So what is dissolution? That a mineral, original mineral in the original rock, that completely goes into dissolve. So there is nothing left over. It is going into dissolve. Suppose a carbonate. A carbonate, that is the calcite or dolomite, it totally goes into dissolution and nothing left. Then you call it a dissolution reaction. It is one of the important reaction which can remove material from the original rock and help in the formation of the secondary rock. That is a dissolution. Number two, the hydrolysis. Now, what is this? Is one of the very, very important process in the sediment formation and the weathering reaction. This is also referred to as incongruent dissolution. What does it mean? Suppose a mineral A that is going through hydrolysis. So what it will do? It will create another mineral B and it will release something. So total dissolution nahi ho raha hai. Total, it is not going directly into the water. It is creating a mineral by means of reaction with water and release some element. This is a very, very important reaction and the most important in the weathering profile. I will give you some example that how really it happens. Now, before I discuss it, I want to know that what is the difference between erosion and weathering?
Weathering means breakdown.
Huh?
Weathering means breakdown. Erosion means weathering plus
I cannot
transportation.
listen to you unless you talk loudly.
Weathering means breakdown, and erosion means breakdown plus transportation.
Weathering means breakup.
Breakdown plus transportation.
Transportation. Or erosion?
Sorry, sir.
Weathering means breakup and transportation.
No. Weathering means only breakdown.
Weathering means only breakup and erosion means breakup plus transportation.
Yes, sir.
Yes. Do everybody agree to that?
No, sir. Actually,
Yes, sir. Weathering
weathering.
is an in situ process.
Actually, yeah, in
Weathering,
situ process.
In
weathering is
situ
a
process. In situ process.
weathering is a बोलो ना
In
बोलो.
situ process. It does
Okay,
not involve
you
any
can give, you can
transportation.
write in chat also. Yes. Actually, erosion and weathering, the fundamental difference between the two, that weathering is a physical plus chemical process, whereas erosion is essentially a physical process. No chemical process involved in the erosion. No chemical process involved in the erosion, but a significant chemical process involved in the weathering. A weathering reaction can generate a new mineral. Erosion cannot generate a new mineral. Erosion, yes, what was told, it is a breakup and transportation. I do agree, but weathering is not that. We can generate a soil profile by means of weathering. And the soil profile, the major thing involved in the weathering is the chemical reaction. We will show that what chemical reaction. And as I said, one major chemical reaction process, that is the hydrolysis, where a mineral A, it is giving way to a generation of a mineral B, which is a chemical reaction. Now, if I say that erosion, yes, breakup, how can? It is all because of the mechanical process, freezing and thawing, the salt generation and dissolution, that the heating and the cooling, all this, that the exposure and the insolation, that the sun ray, all these are the responsible for the erosion process, which is basically breaking the rock and transporting the fragments. But this process cannot generate soil. Cannot generate soil. Okay? Now, coming into the weathering. What basically is a weathering? That there is a huge chemical reaction, dissolution, incongruent dissolution. These are all chemical reactions that are coming into picture. I will also discuss the oxidation, reduction, chelation. All these are chemical processes. And these chemical processes that guide the weather. Okay? So let us see what kind of chemical process. And that I am coming from the hydrolysis. CO2 plus 6 is 2 plus 2 KASI3 Is the equation visible?
Sir, the green marker is invisible actually.
Green is not visible.
No, sir.
I read it. Okay?
Okay, sir.
CO2 plus 6H2O. CO2 plus 6H2O plus 2KAlSi3O8. That is feldspar, potash feldspar. Potash feldspar. 2KAlSi3O8. On this side, it is Al2Si2O5, Al2Si2O5 within bracket OH4, Al2Si2O5 OH4 plus K2CO3, K2CO3 plus 2HCO3. 2HCO3. Is it okay now?
Yes, sir.
Then 2CO2 plus 11H2O plus 2NaLSi3O8. That is the soda feldspar. Two NaLSi3O8. This side Al2Si2O5OH4 plus 2Na plus 4H4SiO4 plus 2SiOH2. Sorry, I'm little wrong. This will not be SiO. This will be 2HCO3. Sorry. Has everybody written it?
Yes, sir.
Okay.
Yes, sir.
Now, what is happening in this reaction? These are all hydrolysis reactions. What is happening actually? You see, your potash feldspar, which you get in the igneous rocks, acidic igneous rocks. This you get soda feldspar, you get in basic igneous rocks. Potash feldspar, you get the quad potash feldspar is a constituent of granite. Whereas plagioclase feldspar and pyroxene you get in the basalts and basic igneous rocks. Now I am showing one reaction from the acidic igneous rock, one reaction from the basic igneous rock. How really that is? So the carbon dioxide, you are putting carbon dioxide in presence of water. Now one major source of carbon dioxide dissolved in water is rainwater. One major source of carbon dioxide dissolved in water is rainwater. In the rainwater, the atmospheric carbon dioxide gets dissolved and that makes the pH of rainwater 4 to 7. Then the neutral is 7 and most of the rainwater, the pH, if you measure the rainwater pH, that is less than 7 and it ranges from 4 to 7. Rainwater. And then when the rainwater, it comes on the surface of the ground. If you have vegetation, so the vegetal litter and the humus generated by the decay of the vegetal litter that can further decrease the pH of this water as low as 2. So the rainwater, which dissolves the atmospheric CO2, which has a pH 4 to 7, and as it comes onto the surface and mix with the humus of the decomposed vegetal litter, then its pH can go as low as 2. And that rainwater, that is, we are basically causing that the CO2 and H2O. It then acts on the potash feldspar, and what it is giving? The mineral A, what I just talked about, mineral A, it is giving away to the mineral B. It is kaolina, clay mineral, kaolina, clay mineral. And what it is doing? It is causing the release of potassium carbonate and the bicarbonic acid. Similarly, the reaction in the soda feldspar, it also creates the kaolinite. It releases soda. This soda then get transported by the river system into the ocean, making the ocean water saline. This soda is carried, it releases the soda. That ocean water is saline. What is contributing that NaCl, for the salinity of ocean water? It is the soda feldspar present in the igneous rock. That is causing finally the ocean water saline. Otherwise, where from so much of soda will come? Now, this soda is released, the silicic acid and bicarbonate. Silicic acid, what happens? Soda, it is transported by the river system into the ocean and cause the ocean saline. Whereas potash, it is not transported. It remains and cause the soil fertile. The fertility of soil that comes from this presence of potash. All our fertilizers, they are actually potash. So this potash which is released by this reaction, it causes the soil fertile, whereas this soda released by the reaction transported by the river system and it goes to the ocean. What happens to the silicic acid? The silicic acid, now silica, for this you have to understand how silica behaves. Silica goes into solution when the temperature is high and water is alkaline. Write it. Silica goes into solution when temperature is high and water is alkaline. Whereas silica precipitates when temperature is low and water become acidic. Is it clear? Now river water is alkaline, and that is why silica remains in solution in the riverine water and is carried and transported to the ocean. This silica, when it reaches to the deeper level of the ocean and where the temperature decreases and the water become acidic because of the increased dissolution of the carbon dioxide, that the deeper ocean water is acidic, there the silica gets precipitated, and that's why the organisms which we get their radiolaria diatom, they have the siliceous taste. Is it understandable?
Yes, sir.
Yes, sir.
So all this silica, where from the silica, the radiolaria diatom, they are getting the silica. They are, and why they are at the deeper level where the carbonate bearing the organism, they are not staying because it is the deeper level below the carbonate compensation depth, and there you get the radiolaria, and because of the low temperature and the acidic condition, the silica gets precipitated there, and radiolaria and chart there, radiolaria and diatom, they make their taste. So it is a good tuning. It is a absolutely good tuning from the continent to the ocean, that how the elemental balance that is basically driving the entire the surface, the organic world, and the different kind of nutrient. You know, the other reaction. This is one reaction that I have listed. The next reaction is oxidation and reduction. Oxidation and reduction. Now, Okay, before going into that, I am saying that this kaolinite is not the only clay mineral that is found. We also get smectite, elite, palygorskite, all these different kind of the clay mineral that can be found. And the formation of whether the kaolinite will form, smectite will form, elite will form, all these are depending on that what kind of climatic condition you are basically in. If you have weathering that is happening, I'm just giving you a general clue. If you have weathering happening in a well-drained system, that means you are doing the weathering of a rock where when the weathering is happening, when the original mineral is changing, immediately the elements it is releasing through this reaction that is taken away from the system. It is a well-drained system. If you have a well-drained system, then there is more chance that you get a kaolinite. If the system is not well-drained, that means there is weathering reaction, but the elements that is released that remain in the system do not go away from the system. It is not a well-drained system. Then what will happen? Then the availability of those cations that will cause the formation of the more complex clay, that means chlorite, the smectite, elite, and so all this, whether the climate is dry, climate is wet, the system is drained, system is not drained, all these basically matters that what kind of clay that will be formed. Now coming on to oxidation and reduction. The most important example that people give in this, that the response of iron. So iron from the +2 state, by oxidation it moved to +3 state. The ferrous to ferric. Iron changes to, and how it does? By the release of one electron. That is how it changes from +2 to +3 by means of release of one electron by the oxidation reaction. This reaction actually provoke the release of one Si4. Release of one Si4 silica, and that vacancy that it creates that basically promote the further reaction. So as you know that the formation of goethite, formation of limonite, so all these FeO, OH2, FeO, Fe2O3, OH2, all these they are basically the reaction, that is the oxidation reaction, and any oxidation reaction of iron that form the rock to be more reddish color. Now I give you another example. It is how important is the oxidation reaction for us. When there was no light, when there was very little oxygen in the atmosphere, when the early atmosphere on the earth, we know that it was a reducing atmosphere with lot of carbon dioxide, methane. And then the atmosphere started gaining the pressure of oxygen. And then this oxygenation of the atmosphere that basically caused the appearance of life. This is the general theory. All of us know that the atmosphere became oxygenated and then light came. Is it the only way, the only oxygen is important for life? No other thing is important for life? For our life, something which is very important, that is the availability of phosphorus. If you take our bones, that the main ingredient of our bone is the phosphorus. How the phosphorus will be available? Then if you see that for our body, all of us are very well known that the people who are taking during the corona time, you people who are taking a medicine called Zincovit. Any of you have taken the zinc supplement?
Yes.
Yes, sir.
Yes, sir.
Why? Why zinc? Why zinc? absolute necessary for our body. Copper, zinc, phosphorus. All these are micronutrients of our body. And none of this would have been released from the rock unless there is increase in the oxygen pressure in the atmosphere and the release and the reaction of the oxidation reaction that basically release these elements from the rock. And that basically help the appearance of the life on the surface of the earth. See how it is beautifully tuned. A weathering reaction, a oxidation reaction was absolutely necessary. One day I will give a total talk on it. Fascinating that what was the need of the life and how the oxidation reaction that basically caused the first appearance of life. It is not that the oxygen pressure come ho jayega. If the oxygen pressure decreases, it will only have problem in our respiration. It is not that. वो तो है ही है. But no life will be there if oxygen pressure will be less. Even if I artificially give oxygen to you, and you are basically taking the oxygen mask and you are getting the oxygen, even then we will not live. Because all other micronutrients of our body, what is required, that is coming by the oxidation reactions of the rock, that will be stopped. So even if I supply you oxygen, we will not live because we will not get any other nutrients what is required for our body, and that requirement will be gone. So it is not that the oxygen pressure requirement in the atmosphere that is only necessary for the respiration. Now, that is the oxidation. Now, next reaction, that is what is called the chelation. Chelation is a organic process, and there you form a organic ring, and that organic ring that basically absorbs the different cations. And by forming the organic ring, an absorption of cations, some material that gets released from the original rock during the weathering process. So an organic interference in the weathering system, that basically is a chelation. Chelation is basically the formation of the organic ring and the attachment of the cations with the organic ring that basically take away those cations away from the system. And that is what we call the chelation. Now, what we have discussed here is that the elements or the cations, they get released and that basically reach to the ocean. Now, ocean water, that is saline. What is the most important, what is the most abundant cations in ocean? What is the most abundant cation and anion in ocean?
NaNCl.
Huh? Bolo?
So NaNCl.
No.
Chlorine.
No. That is why I asked. Na and Cl are not the most abundant cation and anion in the ocean. No. Most abundant cation in the ocean is magnesium. Then comes calcium. And then comes Na. Na is quite low. In fact, calcium and magnesium is to calcium ratio in the ocean water is 5:1. And calcium is much higher than the sodium. Even then, why ocean water is saline? Sodium is not the most abundant cation. Then why ocean water is saline? It is not because of the higher abundance of any cation. It is because of the residence time of the cation. Residence time of the cation. That means if a cation is supplied in the ocean, how long it remains in the ocean water before it gets precipitated or separated out by any mechanism. If you see that the residence time of sodium in ocean water in the tune of 100 million years, whereas the calcium residence time is 1 to 10 million years. That means all organisms, they are making their taste with the help of calcium. And so taking it out from the ocean water, but no one is making it by sodium. So the sodium is remaining in the water. And that is why the making the seawater saline, though it is not the most abundant cation in the ocean water. Is it clear?
Yes, sir.
Yes.
So that is why the ocean water is saline, though sodium and chlorine are not the most abundant cation and anion. Now, just 1 minute. Take little water. Okay. Now this, you all know the Bowen's reaction series, and you all know that the weathering response series. Different minerals, they basically respond differently. And you know that the weathering series, that which mineral will be most susceptible to weathering and which will be the least susceptible to weathering, that basically is the almost reverse to the Bowen's reaction series. If you see the series and then talk about that how really quartz, muscovite, hornblende, alright, this is more or less the quartz is the most stable. And this is most unstable. Now, what is written within the bracket? That is basically anion is to cation ratio. Anion SiO2, so anion is to cation ratio, that is 200. More the anion is to cation ratio, more is the stability. More the anion is to cation ratio, more is the stability. So if the less the anion is to cation ratio, so many of the unsatisfied bond and that basically is cause the more weathering tendency. More weathering tendency. Now, suppose what we basically talk about, that a rugged topography in a dry climate and a rugged topography in a humid climate. A smooth topography in a dry climate and a humid climate. What will be the difference between the two? Actually, if you have a rugged topography in a dry climate, and you are basically the most important process that will be working there is the erosion. There will be very little weathering because the non-availability of much water, it is a dry climate. If you have a rugged topography in a humid climate, then what will happen? Here also you get the more effect of the erosion, because for weathering you need to have a chemical reaction to proceed, and for a chemical reaction to operate for a long period of time, you cannot afford a very steep slope. So if you have a gentle, gradual, undulating slope, that gives you more chance for the rock to stay on the slope and come in the contact with the water and the carbon dioxide for a longer period of time. So a rugged topography in a humid climate, that will be also more the erosion prone, not the weathering prone. Whereas a gentle topography, the role of physiography I am talking about, a relatively gentle undulating topography in a humid climate, that will allow the rock to stay in the same condition in presence of water and carbon dioxide for a longer period of time, and that will give you more weathering reaction and more generation of sediment and the soil. So it is not only the climate, but also the kind of topography I am getting in that climate, that basically is responsible for what kind of the sediment and the amount of sediment and the soil that I will be forming. Okay? Now, in a sedimentary rock, the first what I will be talking about, that how the sediment is generated. Now we are talking about how the sediment is generated. The sediment is generated by the weathering and the erosion reaction. Now what will be the character of this sediment? The character of the sediment will be the grains will be of different size, grains will be of same size, but the same kind of mineral, whether I get, how much I get the clay in that, how much I get the pebble in that, how much I get the sand size grains in that. The different sizes of grains, what basically control these different sizes of grains? The weathering reaction and physiography. It is the balance of physiography and weathering reaction. The more advanced you allow the weathering reaction to proceed, you generate the more finer grained sediment. The lesser you allow the weathering reaction to proceed, but before the weathering reaction is fully complete, you allow the sediment to dislodge, to get dislodged. You get more of coarser grained particles that basically is formed. So the process is that how really you control the entire process of the sediment generation and the type of sediment and its role in the entire sedimentation history. The physiography and the weathering climate, these two in combination guide the entire role of what kind of sediment I will be generating and release in the sedimentary cycle. This is the essentially the process which basically guide and as I discussed that the different kind of element that is released in this. Now this entire process ultimately it forms a soil. Soil as we see it in the present day, or soils that were formed in the geological past, which we can find in the rock record in the form of paleosol. Now this paleosol, what if we identify a paleosol in the rock record, what does it indicate? It indicates that the surface was exposed to subaerial condition, number one. Because if you are not in a subaerial condition, you cannot form a soil. This is number one. Number two, that you actually was in a climate where the water was available. And the reaction of the weathering reaction, as I have already written, that all the weathering reaction, that is a hydrolysis and carbonation reaction. What I said, carbonation and hydrolysis reaction. You are adding water, you are adding carbon dioxide. So these paleosols, they basically talk you that there was a condition in the ancient past when you have this climatic condition, that is the availability of water. How we identify a paleosol in the rock record? First of all, we found the first criteria of the paleosol identification is the presence of the root traces, plant root traces. How we identify the plant root always will be branching downward. नीचे की तरफ branch होंगे, नीचे की तरफ branch होंगे. Suppose if I get something like this, and I get something like this, क्या difference है? एक branching ऊपर की तरफ, एक branching नीचे की तरफ. These are all root traces, and these are the burrows. Burrows will be always branching in the up direction, whereas plant roots always will be branching in the down direction. Okay?
Yes, sir.
So let me now take a I am ending the class today here. We will discuss the soil, we will discuss paleosol and all other things in the next class. Let me first get a little introduced to you.